Hello everyone. So this question was asked to one of my friends in his Google hardware interview. So what you need to do, you need to find VA, VB, VC and V naught here, and the VT value is 0.9. So from VT value we can conclude that it is NMOS. Okay. So these are standard kind of questions. Okay. So what you need to do in this one, first take one transistor only. Okay. Then I will explain it for multiple. Now this is your gate. You all know. Now this is at a high voltage and this is NMOS, so this is drain and this is source. Okay, source. So first what you need to do, just assume a capacitor at source. Okay, at source you assume a capacitor. So initially what is the value of charge at capacitor? 0. So voltage is 0 here. Okay, so here VDS is 5 volt, VGS is 5 volt, VGS minus VT is 4.1 volt. So VDS is greater than VGS minus VT. So the transistor goes in saturation region. These are all very basic things. Saturation region, in saturation region we can replace the NMOS with the current source only. So there will be a constant current charging this capacitor. Okay, so it will start charging. Now it will charge and charge at till what time, till what voltage it will charge? Till 5 volt or 4.1 volt. It will charge till 4.1 volt. Why? Because just assume like we are having 4.1 volts here. Now let us assume we are getting 4.101, not 101. It would like let's assume we get 4.11. So what will be the VGS value now for 4.11? It would be lesser than 0.9, lesser than 0.9, right? 5 minus 4.11 would be lesser than 0.9. Now if it is lesser than VT, then your transistor will be off, so there would be no connection, so the capacitor will be open-ended only. So your transistor can, so your capacitor can charge only up to VGS minus VT voltage only. Okay, 5 minus 0.9, this would be 4.1. So your capacitor can charge till 4.1 only, because if it tries to go above 4.1, then VGS value would be lesser than VT and the transistor will be off. So you will have 4.1 here only. So now VA value is 4.1. Now again take this case, 5 volt. Now we have 4.1 here and this value VB. Again assume a capacitor and till what value it can charge? VGS minus VT. Again till 4.1 only it can charge. Okay. See, you don't need to see anything between these two nodes. You need to see between these two nodes only. Okay. No relation with drain voltage. No relation with drain voltage. The relation is with this VGS minus VT, with this gate voltage. Okay. Look, the only relation between these two node voltage will decide whether it will be in linear region or saturation region. Linear or saturation, but that's not our concern. We are not drawing the waveform here. We are only estimating the steady state output voltage. Like what I am saying, like let us assume it is your VB is charged to 3.7 volt. In process of charging from 0 to 4.1, it goes till 3.7 volt at a certain time. We are assuming. Okay. So what would be the VDS voltage at that time? It would be 0.4 volts. And what would be the VGS value? 5 minus 3.7, it would be 1.3 volt. So VGS minus VT would be 0.4 volt only. So VDS is equals to VGS minus VT. So here as well it is on the saturation node. Now let us assume VB to be 3.6. So if VB is 3.6, your VDS will be 0.5, VGS will be 1.4 and VGS minus VT would be 0.5 only. So again this condition is satisfied. So always it is in the saturation region only. Like I was assuming if it goes in linear or not. So I was just taking some values and checking it. Like take it for 3.9. Again your VDS is 0.2, VGS is 1.1 and VGS minus VT would be 0.2. So again it is in the saturation region. So it always remains in the saturation region. So I was just checking if it goes in linear or not. So again, like till what value it will charge? Till 4.1 volt. Okay, so at 4.1 your VGS value is 0.9, so it can't go down from 0.9, so it will charge for 4.1. So basically what will be the answer? VA equals to VB equals to VC equals to V naught equals to 4.1 volt. So this would be the answer. Okay. I can take one more question here. Let me write it and then explain. Now this is the question. You may write the answer first. Before seeing the solution, you may write the answer. So here, what will be the VA value? VA value will be 4.1 volt. As per the last question only, like it will charge the VGS value can go up to 0.9. So VA would be 4.1. Now here, what will be the V naught value? Here the V naught value will be 3.2 volt because this is 4.1 volts. So 4.1, now this value can go up to 0.9. VGS value can go up to 0.9. So VA minus V naught can go up to 4.9. So 4.1 minus 0.9 equals to V naught. So V naught would be 3.2 volt. But in this series configuration, VA equals to VB equals to VC equals to V naught. Okay, but here it is different. So this question wasn't asked, but they can ask these questions as well. Okay, so this is the concept of past transistor logic. Okay, thank you.